All right, people, here we go. I'm doing this one from home, so if it sounds a little weird or you hear my kids screaming in the background, just bear with me. Okay, so we are talking about sequences in this unit. So the last notes that we took, if you remember, we were talking about two things. Recursive rule and explicit rules. So I was talking about this guy right here, recursive and explicit. And recursive rule, remember, you have to know what the first term is. The explicit rule, you just substitute in. And we talked about those on the notes. So hopefully that sounds familiar. Okay, so an arithmetic sequence. We were focusing on arithmetic sequences today. So that just means if you think arithmetic, I want you thinking addition and subtraction. Okay, so addition and subtraction. Arithmetic sequences, you are always adding or subtracting the same thing. Okay. So again, I'm really trying to go quick to keep this video short, but if you need to pause it, obviously you can pause it. Okay. So here's our first sequence here, and you can see that we added 6 here, we added 6 plus 6 is 12, 12 plus 12 is 18, and you could probably predict the next one is going to be 24. So, well, how do we figure out like what it is each time, maybe when we don't recognize it? So what you have to do each time is you're going to take the second number, and you're going to subtract the first number from that second number. Okay, so you're going to take the second number and you're going to subtract the first number. Hold on, let me get to my notes page here. I just want to make sure I've got it correct here. Okay, so you're going to take 6, our second number, and you're going to subtract 0 from it. Well, 6 minus 0 is 6. Okay, you guys with me so far? All right, and then you're going to do it again. And this time we're going to take our third number and we're going to subtract the previous number from it. So 12 minus 6 equals, well, 12 minus 6 is 6. So you can see that we got the same thing here. And if this is truly an arithmetic sequence, then we should get the same thing when we do 18 and 12. So you're always looking at the previous one, right? So we're going to do 18 minus 12. And that equals 6. So we call this right here a common difference. Okay, they always have a common difference. Okay, and we call that D. So D in this case, or actually it's supposed to be a lowercase d. So D in this case is 6. So I have 3 more examples below, and those 3 examples have either a common difference or they don't. And if they don't have a common difference, then they're not an arithmetic sequence. If they do have a common difference, then they are. So this next one, I'm going to tell you already, it is not arithmetic, but I want you to be able to tell me why. So again, we're going to take that second term and we're going to do 2, and we're going to subtract the first term from it. So 2 minus, well, that's a negative 1, so there's actually 2 negatives in there, and a double negative becomes a positive, and so that's positive 3. So then we're going to take negative 3, and we're going to subtract 2 from it, minus 2. Well, I've got 3 negatives, that's 1, 2, 3 negatives. 2 more negatives, that's 2 negatives, and that's negative 5. So these are no longer the same. They're not the same, so not arithmetic. Okay, so remember our first one, we got 6 each time. Well, this one, we got 2 different ones, not arithmetic. So let's do one arithmetic sequence here. Okay, and so we're going to take that first number, and we're going to go 12, and we're going to subtract the second number from it. So 14. And so 12 minus 14 is negative 2. There's more negatives than positives. And then we're going to go 10 minus 12. And so 10 minus 12 is negative 2. Look, we got the same number. So far, arithmetic sequence. And then we're going to do our last one here, and we're going to do 8 minus 10. Well, that is also negative 2. So that, yes, it is an arithmetic sequence, so we're going to call it arithmetic. Is it? Ooh, I've been making a mistake here. This should be E. Goodness, arithmetic. hey, math is my strong suit, not spelling. Okay, so arithmetic, and D in this case, it's all the same number, is -2. Okay. All right, so our next one, we're at 5 minutes right now, so I gotta hurry it up here. So we're gonna do 6 minus 3. Remember, second one minus first one, that is 3. And then we're gonna do our second one, 9 minus 6. Guess what? 9 minus 6 is 3. So far, arithmetic sequence. But if we get to our last one here and we say 27 minus 9, that's not 3, that's 18. So, not arithmetic. Okay? Not arithmetic because you did have 3 and 3, but that last one right here gave you 18, so not arithmetic. Okay, so there's 2 ways. Once you know it's arithmetic, you actually need to come up with a formula for this thing. And so we're going to come up with a recursive rule. And remember, recursive rule says that we have to have the first term. Okay, so must have first term. So need first term. Okay. Hey, good news. It's right there. We know what it is. So there's 2 notations for this. The first one is function. And that function is going to be f of 1, so our first term. And that's going to be f of n equals f of n minus 1 plus d. And then it's n is greater than or equal to 2. And so we say n is greater than or equal to 2 because we already know what the first term is. We need to know what, we need to be finding the second term. If you substituted 1 in there, you would get f of 0 and you'd actually be going backwards. So you just have to make sure when you substitute n in here, it's 2 or more. And if we want to do it in subscript notation, so remember, subscript is saying the same thing, it's just in a different notation. So a sub 1, there's our 1, is the same thing as f of 1. Okay, and we're going to do a sub n equals a sub n minus 1 plus d. And the same thing goes for this one. You've got to be substituting in, or you got to be finding the next term. So after 1, so it's got to be 2, 3, 4, 5, 6. Okay, so it just has to be greater than 1. Okay, so for this first one, we're going to find our common difference first, and we're going to go 6 minus 0. Oh wait, we already did common difference. We already know that one over here, and we know it works, and so it's 6. So D is 6. Okay, so f of 1, we know what f of 1 is. It's right there. It's the very first term. Okay, and that's 0. All right, so our second one, our second part of the formula, we've got f of n equals f of n minus 1, don't forget our parentheses in there, plus 6, and that's our common difference. Okay, so D is our common difference. That's where we're taking that 6. I don't know if you guys just heard that. That was my youngest, that was Reagan. N is greater than or equal to 2. Okay, you guys good? All right, so if we did that in subscript notation, it would look really similar, except it would just say a sub 1 equals 0, a sub n, so equals a sub n minus 1 plus 6, and n is greater than or equal to 2. So it's all the same thing, and honestly, the only thing you're replacing is D. You're just replacing D. That's it for your recursive rule. So our first one here is going to be, we got to first look to see if it's arithmetic, and we're going to say 2, because we take our second term, and we're going to subtract 3 from it. So 2 minus 3, well, a double negative there becomes positive 3, so that's 5. And then we're going to say 7 minus 2. Well, guess what? That's 5. And we're going to do at least 3 of them. And so we're going to go 12 minus 7. Hey. And guess what? That's also 5. And so we have D or d equals 5. And so if I'm going to put this in function notation, all it's going to say is f of 1 equals -3. So I just took our very first term, it's -3, and we have f of n equals f of n minus 1 plus, and so boom, right there. Oh, not 6, 5. We want 5. N plus 5. And we know that n has got to be greater than or equal to 2. Okay? So it's really, I mean, honestly, all you're doing is you have to know what, you have to memorize this right here. You've got to memorize this guy. Okay? And the things that you're going to be replacing, you're going to say f of 1 equals whatever that first term is. Okay, so remember in this first term, we said f of 1 is -3. Our first problem we did, we said f of 1 equals 0. And the second thing you're going to be replacing is d. You're going to be replacing that d with whatever your common difference is. And you find that common difference from subtracting here. So I'm going to skip these next two. And if you guys have questions on those in class, you can definitely ask me about these last two. But I want to get our videos at 11 minutes already, so I want to make sure I get to the back side. Okay, and we talk about our explicit rule, because the explicit rule is the one that's probably going to take a little bit more math on your part. But again, it is just a rule. You don't have to make n greater than 2, and all you have to know is the whatever place that you're working with. So there's two notations. There's the function notation, and that's going to be f of n equals f of 1 plus d times n minus 1. Okay, that's function notation. And subscript notation is going to be a sub n equals a sub 1 plus d times n minus 1. Okay, so here's our original one that we worked with. We know that 0, 6, 12, 18. So we already know that d is equal to 6, because that's the very first problem we did in the notes. If you aren't sure where we got d equals 6 from, you need to check out problem number 1 that we did at like a minute 30 seconds. Okay, and now we're going to take our formula and we're just going to bring function notation down. We're going to say f of n equals, well, our f of 1, if we look at our function notation, it says f of 1 is 0 right there. It just says our first term is 0 plus d. So we're going to substitute d here in 6, and we're going to say n minus 1. Okay, so here's where this gets a little bit more, like you've got to do a little bit more math. At this point, this problem is ready to simplify. You must simplify. You must simplify. Okay, and all that means is you've got to distribute your 6. And so it's going to be f of n equals 0 plus 6 times n. 6 times n is 6n. 6 times -1 is -6. And since this is 0, it's just going to stay -6. So in this case, we have f of n equals 6n minus 6. And you're done. Right there. Okay, so let's do one more, and then actually let's do two more. We're going to do one more in function notation, one in subscript notation. Okay, so the first thing you have to find for either the explicit rule or the recursive rule is you have to find d. You need to know what d is. Okay, so d, we're going to do the second term. So 0 minus, there's 2 negatives there because you're subtracting whatever this is, so it's 2 negatives. And negative plus negative times a negative is positive, so this is actually 5. Okay, and you can see -5 plus 5 is 0. 0 plus 5 is going to be 5. So I think it is, you can already start telling that it is an arithmetic sequence, but we want to double check to make sure, and we need it at least 3 times. So we're going to go 5 minus, well, the previous term is 0, so 5 minus 0 is 5. We're on the right track here. We pretty sure it's an arithmetic sequence. We're going to do 10 minus 5 now. So 10 minus 5, and we've got 5. So d definitely equals 5. Okay, and then we're going to take our explicit rule, and I'm just going to write out the whole thing so you guys can see exactly what I'm replacing here. Okay, so here's the original rule, the original formula that I gave you. And the things that we're going to replace are f of 1 and d. So we got f of n equals, well, f of 1 is whatever first term is. So we're going to replace that whole thing with -5. And then we found d right there, and d is 5 and n minus 1. Okay, so here's where people will make a mistake. They'll say -5 plus 5 is 0. You cannot do that. You have to distribute. This is multiplication. It's order of operations. You've got to distribute before you can start combining like terms. So we've got f of n equals -5 plus 5 times n is 5n. 5 times -1 is -5. And you're going to combine like terms. And like terms are things that have either the same letter or no letter and the same exponent next to them. And so you have 5n minus 10. Done. Okay? So your next one, let's do subscript notation just so we get a subscript notation in there. I'm going to tell you right now, just in interest of time, our d does equal -3. You would do 4 minus 7 is -3, 1 minus 4 is -3. I don't have time to do that right now because we're almost over the allowable time for YouTube to upload. So I'm going to go a sub n, and I'm just going to write out the whole formula, plus d times n minus 1. Okay, and so we know that d is -3, so the things that we're going to replace are d, which is -3, and a sub 1, which is just our first term. So a sub n equals 7 plus -3 times n minus 1. Okay, so be careful when you're distributing this negative because you've got a double negative with the -1 and -3. So this is going to be a sub n equals 7 minus 3n plus 3. So if you're wondering what happened to the positive there, it's plus -3, so it really just says -3. So -3 times n is -3. -3 times -1 is positive 3. And then you've got a sub n equals -3 and, whoops, sorry. -3 plus 10. And there is your explicit rule, okay? All right, so I'm going to write down the answers for all of these so you can double check your work later on. And this one is going to be f of n equals 3n plus 1. Okay. You have number 10, which is going to be the recursive rule. And this answer is going to be, oh, you got to find the first 3 terms. Oh, this is already a rule given to you, so I'm actually going to let you guys substitute in. This should be review. Okay, this is all review for you. That's all from the last one. You're just substituting in your t-chart, your x and y, or your n and f of n, or a sub n in this case. So this one's going to be n and f of n, and our last one is going to be n and f of n because it's in function notation. Okay, well, peace out, people. Hopefully I got to go quick enough. Okay, hold on a second. Reagan, come here. Come here and say goodnight to my students. Say goodnight.
Good night.
Say have a good day.
Have a good day.
Bye.